Hello everybody. My name is Manuel Matos. I am a graduate student here at the facility. My colleague Krishna, who is also a graduate student, is gonna be the cameraman today. And we are going to show you the facility. And anything that you come up, any question, please write it down in the chat, and later your question will be answered. So we'll start going inside the control room of the facility. Uh, we'll show you how the data is acquired, how we use of the telepresence, which in these times is very helpful for everybody. So please welcome to the wall of wind. So the first thing that we're gonna see in here is the control center, and we're gonna go directly to the control room where everything is controlled. In this working station, we can see how the fans are controlled and everything is turned on for the tests. For when the tests are going on, we can make use of this system, which is a remote vision or visual system in which we can monitor the tests, as we cannot be inside the wind tunnel for safety when the fans are on. In here, we also have we have two systems for telepresence, which is the system of cameras that we use here, the engineers use, and there's also a system of cameras which is different from the ones we use, that is provided to the users that can watch the tests from a remote place. So you can move them differently from those. And this is the system that is used to acquire the data for pressures, wind measurements. We can actually also get different values from strain gauges, load cells, accelerometers, inclinometers, and so forth. So now that we've seen the brain of the facility, now we're going to see the muscle. So for that, we have to go over here. And one of the things that we take very seriously is the safety. So everybody across this door has to wear a helmet. You don't have to now, but I have to. So we go through here, and we are gonna see the fans, or the intake side of the wind tunnel. See now is the fans that provide us with the necessary wind or air that we need to push through to the wind tunnel to reproduce our hurricanes. These are 12 fans of 700 horsepower each that provide us with the power of 8,400 horsepower. So that's how these fans have been set up in a radial position so that we are able to push the air through. Now, only with the fans, we're not able to produce the 157 miles an hour. So we take advantage of a venturi effect, which we contract the area which the air goes through, and then we speed up the velocity of the flow. So now we're gonna go to the exhaust of the wind tunnel, and then we're gonna get inside the wind tunnel. We are gonna be the flow conditioning chamber, which provide us with the ability to modify the wind profile, as Dr. Chaudhry was mentioning in his presentation. We can modify the wind profile to different exposures or terrains, which are open, urban, or suburban.
Manuel, can you tell the audience how tall you are so they can appreciate scale?
Hey, Tracy, I just replied to this question. Each fan is approximately 6 feet diameter.
Okay. So this is the flow conditioning system or flow conditioning box. It consists of the three triangular columns that you see in there are adjustable, and those are the spires. And that is a system that works together with the floor, the little squares in the floor that are called automated roughness elements. Together, they work to condition the flow and come up with a profile or atmospheric boundary layer that we want to. And also in those columns is where we install water nozzles. So we inject the water whenever we want to reproduce wind mixed with rain, which happens in a real hurricane. So when the air exits from this uh, conditioning box, we get to the turntable where the models are installed. So this turntable can rotate so that we can test at different wind angles of attack. And in this particular case, this special rig is been installed in here to measure actually the profile of the wind for a test that's been going on. As Dr. Chaudhry mentioned, we have different or different possibilities to test small scale buildings or full scale or large scale. In here, we can see a model that was tested some time ago. It's been pressure tapped, and it was studied to see the effect of the wind on this particular building. It's a small scale, and we have tested it some time ago. But we also can have a big model like this one, and this is not a complete building, it's just a component of the building, as Dr. Cisis was mentioning too, like a components and cladding and so forth. So this building, you see some little wires in here. This is all instrumentation, strain gauges, accelerometers. The other side of the building has pressures. So it's been studied for, as we call it, a dynamic side and a static side. We also have the cameras that I was mentioning inside. If you see the cameras here at the top, is two sets of cameras in the west side of the facility and two at the east side. The bottom cameras is the ones that we control inside the control center, and the top camera is the one that the user can control when they are watching the tests remotely. We also have a crane that can be used to move the models around, put them in place in the facility in the turntable, and that is something helpful when we are moving very large or big models. Now we're gonna go and see where the models get prepared, built, sometimes instrumented. It will depend on what type of instrumentation sometimes happens here in the staging area, as we call it, or sometimes when the model is in place. So this is the staging area, and this is we have all the materials to build the different models and where things get prepared to be tested. In the back, you see some fans. Those are for a future small scale wind tunnel that we are gonna have here. And as you saw in the previous presentation that Dr. Chaudhry was showing, that is a 1/20 scale of the full scale wall of wind. And that is where some models can be pre-tested before we actually test it to be put in the big wall of wind. So here we have a machine shop where we can make things and build the models at your requirements. And so that's basically it. The last thing that I want to show is that this facility, since we are testing different things and we test at such high wind speeds, there are some times in which we do destructive testing and things can get damaged and then windborne debris is observed. So this net that is in the exhaust of the wind tunnel is to protect anybody or the surroundings of the facility when there is possible debris flying due to the destruction or the damage of the models that are tested in the wind tunnel. So that's all we have for the facility, for the virtual tour. If you have any questions, put them in the chat and they will be answered. I hope you enjoyed it.
Thank you, Manny and Krishna. Thank you very much. Very well done. I think we already answered a few questions in the chat box. I wonder if we have more. Let me see.
Yes, I believe Elena has a question around the dimensions of the actual test section.
Yes, I saw that and I was about to reply. So another dimensions of the actual test section, as we consider, it's an OpenJet section, right? Yeah, this is the OpenJet section. So we consider the test section to be the same dimension as the dimension of that box that you see at the end of the flow management box, as we call it. So the width of that is 20 feet wide by 14 feet high. So that's what we consider as also the test section dimension of the wall of wind, as 14 feet by 20 feet. Because as you can see, the test section is kind of open. So this is the best dimension that we can kind of allot to that as a test section. Greg, how are we doing on time?
Yeah, I think we're good on time, but why don't we, unless there's, I don't see questions there, so why don't we invite Hassan Kareem? I'm sure he always has lots to share with us. So Sam, if you want to grab the screen and talk about experimental and computational simulation of wind pressure and forces on buildings.
I believe we have one question that slipped in from Maria. Can you guys see that in the chat? What is the smallest length factor you use?
Yes, I see that. Let me see. Am I? Yeah. I'm not sure what is meant by the smallest. Let me read the question again. What is the smallest length factor? Okay, I think you're talking about probably the scale. So if that's a scale, then it is, we have done testing as small as, let's say the balcony model, which is a 1 to 180. Typically, we can also do 1 to 100 scale for low-rise buildings. But again, that can be done in any other wind tunnel. So we think that our strength is more go towards the large scale. So at full scale, of course, everything is 1 to 1. And we have the components that are replicated as 1 to 1 as the real materials and systems. But we have also done large scale testing in terms of, let's say 1 to 2, 1 to 3, 1 to 5, 1 to 6, and those kind of very large scales. And we have a analytical theory approach, which was originally developed by Dr. Peter Orwin. It's called the partial turbulence simulation, because when you go to very large scale, like 1 to 1 or 1 to 6, it's not possible to simulate all the turbulence. And there is a theory and there is a paper also which we can share, which uses the PTS technique to compensate for the missing turbulence for large scale testing. I think there is a question on the PIV. What is the measurement? Okay, so the PIV, we can do 2D, but we can also do like the tomographic or the 3D. So we are going to have that capability in our facility, hopefully in January or February, because we purchased everything, but because of the COVID, things have been delayed. But once we have it, we are going to have both 2D and 3D PIV technique at a very larger wind, at a larger field that's available than in the conventional facilities, and at very large wind speeds. So I think we can do very high Reynolds number flow and look at the effect of the Reynolds number on the flow or on the fluid structure interaction.
Well, I think there is another question related to the scale. What is the big length scale factor in wind testing? From Maria. For dynamics, it's regularly 1 to 2 or 1 to 4. That's the continuation of the question. Arindam, do you want to take this question?
You can answer it, Amal.
Well, the typical length scale that we have in the wall of wind, we can go up to 1 to 5. Again, it depends on the size of the building. We don't want to block the test section. We have some, requirements to satisfy in terms of the largest length scale. But typically we can go for 1 to 5, 1 to 4. But again, it depends on the dimension of the building or the component we are testing. For dynamics, no, we have different other requirements for dynamics. We have to satisfy so many scaling factors, not just the length scale. And I will address that in the aeroelastic testing presentation tomorrow. Thank you.